Hi guys, today I want to look at Azure Container Apps. This is a fairly new offering on Azure for running containers. It's a little bit different than what we've seen so far with Azure Container Instances and Azure Web Apps for Containers. This one is designed for running containers in general, yes, but it's more oriented for things like microservices. I want to talk about it from two different angles. I'm going to do two different videos on this particular technology. One is going to be around just running containers in general on this. So this would be just any old container that you might want to put onto Azure and how you could use container apps to run that. Then another one is going to be looking at Dapr, which is a container framework for building microservices. So it's got its own opinions and its own way of doing things, but it's a very powerful technology that's very useful in the context of containers, specifically ones that you want to scale out and have loose coupling between the containers and secure communication. And there's a lot of things that go into making Dapr work. In any case, we're mostly going to be concerned about the former today, and that's just running containers in general. I like to think of container apps as a managed Kubernetes experience. Now, it's not Kubernetes in the way that Kubernetes is typically exposed in the cloud. With this particular offering, you're not going to be grappling with Kubernetes or any of its complexities, but under the hood, Container Apps is going to be running a version of Kubernetes. Instead of building out Kubernetes manifest and having to wrangle all of the networking and figuring out all the logging and all of this complexities that go into building a container environment on Kubernetes, this kind of just takes that away from you and does a lot of it for you. So you don't have to worry about the logging story. You don't have to worry about the networking or the storage. A lot of that's just built into the framework. Instead, you just basically deploy your apps to it and it will handle all of those details. So you can connect these to private networks, you connect these to storage if you want to use permanent persistent storage. It also manages the scaling for you. You don't have to manage VMs. You don't have to patch Kubernetes. You don't have to install any of the kind of monitoring tools. It just basically takes care of a lot of those details for you. The other advantage of using something like this is it's a serverless billing model. So with the other two options that we looked at previously, we had container instances and we had web apps for containers. And container instances was a serverless billing model, while web apps for containers was based on Azure App Services, where you had to have reserved capacity. So unlike Kubernetes, you don't have to reserve capacity in this. Basically, you can reserve a specific amount of CPU and RAM for the duration that your app is actually running. And whenever you scale down, you basically relinquish that CPU and that RAM, and you're only paying for the time that you're actually using it. So it's much more like a container instance in that you're only going to be billed for the time that you're using and no more and no less. But it's kind of like container apps and kind of like Kubernetes, where you have the ability to do things like storage and scalability and have a more contained, isolated environment for the apps that you're running. You can have apps talk to one another. You can have a lot of those things that are a part of a container environment that's just kind of baked into the platform. So with all of that, it creates a very powerful service on Azure that's completely serverless, but at the same time gives you the ability to have something that's very flexible at the same time. So this is probably my most favorite of the offerings on Azure for running containers, because it does offer a lot of power while abstracting away a lot of the complexities that you would otherwise need to have if you're going to build this yourself. So creating one of these is pretty straightforward in the Azure portal. So I'm going to go over here to create a resource, and I'm just going to type in container app right here. And this is going to take me to the marketplace. I'm going to select container app from Microsoft and just walk through the wizard. And this is going to create a resource group. So I'm going to create a new one, and I'm going to call it Blaze Games Container App or something like that. So I'm going to deploy some of my demo containers to this. And I'm going to call it my first container app name. I'm going to call it Blaze Container App, Blaze Keen, because this is going to deploy Commander Keen. And I'm going to choose a new container app environment right here. So you basically tell it what you're going to be running, what resource group you're going to be in. Then you pick a region. Then you want to create a container app environment. And a container app environment is basically the environment that provides isolation for all of your container apps. So you deploy container apps into a container app environment. The container apps are a set of containers that are basically going to run as a set. So you can scale those independent of other container apps in your environment, but you would create a set of containers that can communicate with one another that all run inside of a container app environment. So you can create a new one here. And this one gives you the ability to choose what kind of environment that you want. And I'm going to call mine Blaze Retro Games, because I'm going to deploy Commander Keen and RetroArch to this. And you want to use the consumption model, which is the only one that's in production right now, but they have this preview one that's consumption and a dedicated workload. And you can enable or disable zone redundancy. If you want to have zone redundancy, you have you incur a little bit of costs for the ingress and egress between the zones in an Azure region. If you want to enable that, it provides better availability, but you don't have to have it for your particular app. Now, on the networking side, you can integrate this with a virtual network, so you can attach your container app environment to a VNet. You don't have to do this if you're going to be running this as just a container or an environment for apps that you're not going to be using integrated with a VNet. You can disable this and select no, but if you want to integrate it with the VNet, you can. I don't need to do that, but I'm going to leave it as is. I'm going to create this one right here. So my next pane is going to tell me all about the container that I'm going to run on this. So my container name is going to be Blaze Keen, and I'm going to use a public container from Docker Hub, and it's called Blaze/DOS game. And this one has Commander Keen installed on it. And now for this to run, I need a little bit more oomph behind it. So I'm going to give it a single core with 2 gigs of RAM. But notice the scales that you can throw at this. Anything from a quarter CPU and a half gig of RAM up to 2 cores and 4 gigs of RAM per container. So it's not for the entire application, it's per container. So if you say scale this to 10 containers, each of those individual containers will allocate the resources that you assign to it. So if I allocate 10 containers at 2 CPUs and 4 gigs of RAM, I'm going to have 20 CPU cores and a total of 40 gigs of RAM for that particular scale that I'm going to be running. For this particular container, it's a little bit heavier than a trivial container. So something 1 core with 2 gigs of RAM ought to be sufficient. Might need a little bit more than that depending on the game that I actually run in it. So I'm going to try that, and I can scale up later if I need to. So for the next pane, this is where I'm going to set up the ingress. So I can attach my container app environment to a VNet like we saw already, but for this to be exposed publicly on the internet, I need to set up ingress on this. And I can choose one of 2 instances here. I can limit it to the container app environment. So that allows for traffic from the container app environment to get into this container, or I can accept it from anywhere. If I would have enabled the container app environment on the VNet, then this would light up and I could choose traffic from the VNet if I wanted to. So that allows me to put things like application gateways and things like that in front of this if I wanted to. But I'm going to say accept traffic from anywhere. And then I'm going to select HTTP for the ingress type. And then I'm going to ignore client certificate mode, and the transport is going to be HTTP 1. I'm going to allow insecure connections, and my target port is the backend port. So this is going to be port 80 on the backend. And I don't really need session affinity, but you can turn that on if you want to. That basically means that if a connection is established from a client, the container app environment will attempt to redirect all repeat traffic from that client to the same container. So it manages that in the backend. So for tags, I don't need any tags. I'm going to review and create. And then I'm going to create this and let this finish. So that's done deploying. Let's go to the resource right here, but this is going to bring me to the container app itself. So I'm going to go back out to the resource group in a different tab to kind of look at the container app environment to show you that it created that. It created a log analytics workspace for the logging. So the container app environment actually is the shell, as I said, around the various containers. So if we come down here to apps, we can see that I have Blaze Keen deployed to this. I'm going to deploy another one in just a second, but this is the same as this tab right here. Now, each application that I deploy to this is going to get its own endpoint. So it's going to get a URL that's going to be unique to a particular container app. That's a combination of the container app environment and then the container app name itself. And so I'm going to take this right here, copy this endpoint right here. Since this is HTTP, I should be able to pull this up and get my Commander Keen container to pull up. So this gives me a list of files. And then if I click on VNC, this is going to connect to the backend. And this has a super secure password 1. And this is my container app running right here. So if I install this, it's just going to install Commander Keen on this particular container. And now I can run a game. This is running on a container and then streaming the results back to a browser. And then I can play this old DOS game using the browser. So all the input comes from the keyboard. So this is not exactly a trivial app, but it is an app nevertheless. So I do like to use this one for demos because it's not exactly some kind of trivial example that it's a little bit more than a hello world example. It does require some level of CPU and some kind of backend technologies to make all this work. In fact, this is actually using WebSockets for the streaming component and for the sound component as well. So with this particular one in mind, you can see that it's running fairly well on a single core with 2 gigs of RAM. It'd probably run a little bit smoother if I had a little bit more compute horsepower thrown at it. But I'm going to deploy another container to this so you can see that I have multiple containers running in a container app environment. So to deploy the next container, I'm going to go back to my container app environment right here called Blaze Retro Games, and I'm going to create a new one. And I'm going to call this one RetroArch. I'm going to call it Blaze RetroArch. And this is going to install RetroArch in a container. So this is a platform that allows you to run a lot of different kinds of game platforms like Atari and Commodore 64 and PC games and SNES and Nintendo and so on. So I'm going to put it into the same container app environment that I already had. Now the container is going to be very much like I just did. And this particular one, I'm going to choose a Docker Hub container and it's called Blaze /RetroArch. And I don't need to override the command. And this one I'm going to throw a little bit more CPU at it because it's a little bit heavier than my DOSBox demo. Again, it's going to require ingress. I'm going to do HTTP. I'm going to ignore, accept traffic from anywhere. I'm going to do ignore on that guy. I'm going to allow and secure connections. It's running on port 80 in the back end. And everything else should run just fine. And then I'm going to create this container. And we'll come back when that's finished. So now that that's done creating, I'm going to go ahead and go over to this resource. Now this is currently running, but there's one thing I want to do to this before I show you this particular demo. I want to add some storage into this particular mount. So to do that, what I'm going to do is I'm going to come over here to my container app environment, and I'm going to add in a file share option for this particular container app environment. So to do that, I'm going to select under settings, Azure files, and this is where I can add in a file share. Now it's going to look for a file share name. So I'm going to call it ROMs for my file share name. And I need to give it a storage account. Now I've already created a storage account that I'm going to use for this particular purpose. And this particular one, I have a set of file shares already created called ROMs right here. It's just an SMB file share. So to populate this particular form, I'm going to add the storage account name, which is called Blaze Game Storage. The storage account keys is down here under access keys. I'm going to show that, and I'm going to copy the key, and I'm going to say put that into storage account key, and then the file share name is under Azure Files right here, which I just simply called ROMs. So you can either copy or just type that in, which is very easy to do. And I'm going to assign read write ability and click add. And now this is added to my container app environment, and then I'm going to click save. And that's going to update this. Now, I couldn't add this during the creation process using the wizard. Now you can do this all through automation, but to add it to the container app after it's been created, you can come down into your container app itself, and then you can go down in containers. And this is going to show me the containers that I have inside of my container app. And if you come over to mount volumes, you can see you have secrets, ephemeral storage, and you have file shares. So secrets would come from something like a key vault, and then file shares would obviously come from the file share that I just created. So I'm going to go to edit and deploy this particular one, and I'm going to come down here to my container name right here, and then I'm going to come to volume mounts, and then I'm going to open up file shares. I'm going to choose ROMs, and then I'm going to put it at the mount path of ROMs inside of the container, and then I'm going to click save. And then I'll click create, and then that's going to create a revision. So it's basically just going to re-provision the container, and then it's going to have a revision URL that I can use. But I'm mostly interested in just getting that volume added into the container. So let's let that create, and we'll come back when it's done. So it looks like everything has created now. So let's go ahead and launch this guy. I'm going to launch it in a new window, and it's going to pull up something very similar to what we just saw with my other Commander King container. I'm going to launch a VNC right here. but this one is going to load RetroArch. So I'm going to configure this, and then I'll come back after I've configured it. So I took a few minutes to configure RetroArch. Now what I'm going to do with this is actually use that folder that I mounted into the container to load content. So I'm going to go over here. I'm going to browse out to that ROMs folder that should be out here in the root. And currently there's nothing in it. So to remedy that, I'm going to upload something into that particular file share. So I'm going to come over here to ROMs, and I can drill down to this, and I can upload, and I'm going to upload a simple ROM into this. So I'm going to call it, I think it's called MarioKart SFC, and that's going to allow me to upload a ROM into this particular folder right here. Now that that's uploaded, I can take that, and I should be able to go back into the parent directory and come back into ROMs, and there it is. So if I launch this, you should see Mario Kart come up onto my screen. And now I have Mario Kart running on a container, and this one is going to run a little bit more less smoothly than I'd like it to on this particular configuration, because this is running in a little bit less CPU than I would probably throw at this particular platform. But in any case, it is running pretty well, and I think it is a very playable game, but with this particular environment. So this is running on my same container app environment as my Commander Keen demo that I just ran. So that means that I have two different containers running in my container app environment. So that's sort of like a Kubernetes environment, but this is more for general purpose containers. So I want to review this and look at it through a different set of lenses though, and that particular lens is going to be using Dapper. And Dapper, if you know anything about it, is basically a framework for microservices. So the demos for that are going to be a little bit less glitzy than this, because I'm going to build some Dapper apps and then use those to show you how the containers will communicate with one another. But this is going to show you that you can deploy just about anything to this, and this is all running inside of a container, and the commands are being sent back through the container. So, and it's not using any kind of standard framework. In fact, it's using some old some old Linux-based context using X server and different things like that to actually run these games inside the context of a container, and then it's just streaming these back over VNC to the browser. In any case, it's just a fun demo, and you can see that it works fairly well. So this is the great way to run containers on Azure. It's, again, very versatile in what you can run with it. There's a lot of options for the kinds of containers that you can run on it. You can run the kind of more general purpose ones like I was doing today with these two demos that I did using RetroArch and Commander Keen. But you can also run Dapper apps on it as well, which is a framework for microservices. So all of this stuff combined really makes for a very rich environment for running container apps of all kinds in this environment. So I really do like this for kind of my first go-to choice for apps on Azure when it comes to running apps in a container. It's because it's both serverless, it's very flexible, it gives you a lot of ability to scale, and it has a lot of options that are very common for apps like storage and networking and secrets management, and all those things that go into making apps run in the cloud. So we'll look at Dapper next time, and we'll dive into what is Dapper and understand what that is and how it works, and then we'll deploy Dapper apps to Azure Container Apps, and we'll give you a full scope of everything that you can do with Azure Container Apps. So if you like this, like the content, like the video, share it with your friends, subscribe to the channel, and look forward to that next video we'll be doing on Dapper.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up, or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.